Right, we're just going to go through the C9 atmosphere test. I'm going to go through the answers and then maybe explain a few of the key ideas as we go along for the questions that people struggled with. So the first thing, got our factual recall questions. It says, name 2 greenhouse gases that are increasing because of human activity. Well, there are 3 greenhouse gases that we have to know about: methane, carbon dioxide, and water vapour. Humans can't really increase water vapour because it will then fall as precipitation, rain, so we'd have methane and carbon dioxide. A lot of people for this next one said nitrogen, but the crucial word there is the early Earth's atmosphere. The early Earth's atmosphere was formed by volcanoes, so the most abundant gas in the early Earth's atmosphere is carbon dioxide. The most abundant gas now is nitrogen, but then it was carbon dioxide. The next one, again, a lot of people got this one wrong because they didn't write a fraction, they wrote a percentage. So it's 78%, which is, it says approximately, which is about 80%. So the fraction is 4/5, 4/5. This next one is a straight percentage, it's 21%. I've already mentioned what produced a lot of the gases in the early Earth's atmosphere. It's volcanoes erupting. Methane is CH4. Now it's important when we write these that we write them correctly. You might not know how to do this, but it's CH4. Every element has a uppercase letter. When you're writing these numbers, they want to be what we call subscript. So what you do is you right click on font, subscript, and that's correct. It puts it down the bottom. So here we're going to write ammonia, which is NH3. A few people wrote NH2, but it's NH3. I've got a button up here where I've just put it, so it's subscript. Describe 2 reasons why the concentration of carbon dioxide decreased from the early Earth's atmosphere to around 200 million years ago. Well, there's 4 possible reasons. So some carbon dioxide dissolved in the oceans. Some was used by taken in by plants and algae. During photosynthesis. Some was trapped in fossil fuels such as coal, oil and natural gas, and some was trapped in sedimentary rocks, e.g. limestone, which is calcium carbonate, and carbonate is CO3, similar to carbon dioxide, which is CO2. Almost everyone got this next one right. So the type of wavelength is short wavelength radiation made by the sun. Again, lots of people got the this one correct. So why did oxygen start to appear in the atmosphere? It was because of plants and algae. And then again, we're looking for our key word. So that's how we photosynthesize. So I did photosynthesis. Define the term carbon footprints. So this is the amount of CO2 emitted by a person or product during its lifetime or for a specified length of time. 2 ways humans have increased the concentration of methane in the atmosphere. Again, loads of people did really well on this. So one of the ways is by sending waste to landfill, where it decomposes and releases methane. And the other way is by cattle farming. Some people just put farming, but there's lots of types of farming that don't release extra methane, so it's got to be cattle farming. 2 ways that humans can decrease the concentration of carbon dioxide in the atmosphere. So there's lots of ways. So some people wrote about carbon offsetting, which is when you plant trees in one place to compensate for carbon dioxide emissions in another place. There's carbon capture and storage, which is where carbon dioxide is captured, liquefied and then stored undersea. There's more efficient devices, e.g. cars, alternative forms of energy, wind turbines. So there's quite a few there to choose from. Sulfur dioxide, now this was one of the lessons that I've given for you to do. So sulfur dioxide is a pollutant produced when particularly coal burns. It rises up into the atmosphere as a gas, and then it reacts with water vapour and it forms sulfuric acid, and that then falls as rain. So one of the consequences is acid rain. Another consequence is it can cause respiratory problems, particularly if you've got asthma. Particulate pollution. So again, this was another one I'd given you to do. Particulates are produced when fuels don't burn completely. If you ever see a car emitting a lot of smoke, what it'll be emitting there is particulates. All cars emit some, but it's particularly when the fuel doesn't burn completely. It's why a lot of cities, if you go into cities where there's old stone buildings, a lot of them will appear like dark grey or black because of the particulates. It's soot, basically, tiny particles of carbon. So it's incomplete combustion of the fuel. We'll do about incomplete combustion later on in the course. And then two consequences of climate change. People did really well on this. So droughts would be one. We talked about increased wildfires. We talked about sea levels rising because the ice caps are melting. Changes in migratory patterns of birds, etc. Could have like desertification. There's many on there that you could have got. So I think I allow pretty much any reasonable answer. Coral bleaching, I think quite a few people wrote. Then we get on to the exam questions. So generally people did really well in that first section. Exam questions are a little bit harder, and also it's kind of hard to kind of edit this work. So I'm just going to show you a couple of ways to do that now. So the amount of carbon dioxide in the Earth's atmosphere decreased as the carbon dioxide, so that word is dissolved. And sediments were formed when carbonates were produced. So sediments, basically little creatures in the sea, tiny plankton. They build their shells out of calcium carbonate, which needs carbon dioxide, and they take that from the ocean. And then they die and fall to the bottom of the sea, and that's what we call a sediment. The next one, what I do for these boxes is just highlight them. So algae and plants use carbon dioxide and water to produce oxygen. What's the name of this process? Well, it's photosynthesis. I'll highlight it. The word equation, well, plants need carbon dioxide and water. Tells us that both. And they produce oxygen. Quite a few people didn't get that, but it's, if you look up here, it basically tells you. The next one, again, it's all about how you format it. So I'm just going to highlight, so carbon dioxide, that's very low amounts, so that's less than 1%, actually 0.04. Nitrogen, and it's worth saying this is the approximate percentages, not the absolute percentages. Nitrogen's very high, so I'm going to highlight a different colour, and that one's about 80, it's 78. And oxygen, again, I'll highlight the third colour, and that one's 21%, so that's closest to 20. Why is increasing the amount of carbon dioxide change the global climate? it actually wanted a fairly simple answer, but I would say stops long wavelength radiation escaping the Earth's atmosphere. Ooh, scapting. So warming the Earth. So we're kind of linking it to the greenhouse effect. How can countries reduce carbon dioxide emissions? Only burn methane. Well, when you do that, produce carbon dioxide. Use waste plastic bags as fuel. Produce carbon dioxide. That one won't. This is probably the maths one later on. This is probably like the poorest done one. So it says about 3,000 million years ago, carbon dioxide was one of the main gases in the Earth's atmosphere. About 400 million years ago, plants and trees grew on most of the land. When the plants and trees died, they were covered by sand and slowly decayed to form coal. So let's highlight some things. So plants and trees grew on most of the land. When the plants and trees died, they were covered by sand, sediment, and slowly decayed to form coal. Describe and explain how the composition of the Earth's atmosphere was changed by the formation of coal. So, first thing we'll say is plants take in carbon dioxide during photosynthesis. This reduces the CO2 in the atmosphere. Plants died, and the carbon inside them transforms into fossil fuels. And then I'll just make another point. So if they had rotted or decomposed, the carbon inside them would have been released. So it being a fossil fuel, it being coal, would stop it being released, and the carbon gets locked away. Right, then next one. Say coal is burned in power stations to release the energy needed by industry. Carbon dioxide, water, and sulfur dioxide are produced when this coal is burned. Name the three elements that are in this coal. Wow. We're producing three products here. A combustion reaction, which is one that burns, it always reacts with oxygen. So carbon dioxide is CO2, so that contains some oxygen. Water is H2O, that contains some oxygen. And sulfur dioxide is SO2, so that contains some oxygen. So we can almost discount the oxygen. Everything else must come from the coal. So the carbon in carbon dioxide must come from the coal. It can't come from the oxygen. The hydrogen in water must come from the coal. It can't come from the oxygen because oxygen doesn't contain hydrogen. And the sulfur in sulfur dioxide must come from the coal because oxygen doesn't contain sulfur. Oxygen contains oxygen. Right. Yeah, no one got this one right. And quite a few people gave it a good go, but they forgot that the formula of nitrogen is N2. The formula of oxygen is O2, and that forms NO2. I'm just going to make the subscript. And then you'll notice it's not balanced. It's one of the things it says a balanced symbol equation. I'd still get a mark for what I've done so far. So what I need to do is make sure there are equal numbers of atoms of each element on either side of the equation, so the products and the reactants. Currently, there's not. Currently, on this side, there's 2 nitrogen and 2 oxygen. On this side, there's 1 nitrogen and 2 oxygens. The oxygens are okay, the nitrogens aren't. And I think we've done a lesson on this in a couple of lessons actually when we did our first chemistry topic. So all we can do is multiply the chemicals that already exist. So we can put numbers in front of them but not anywhere else. So this, I'm going to put 2 there, and that basically times all of NO2 by 2. Suddenly that goes up to 2 nitrogen, but not just 2 nitrogen. Get 2 times 2 oxygen, so that's 4 oxygen. Can you see how nitrogens are okay now? We've got 2 and 2. So then we need to make our oxygens equal. So if I put 2 there, that's 2 times 2, so that's now 4. And that's equal. So we're done. Then the next one, we get a graph about emissions of oxides of nitrogen in the UK. It says calculate the percentage decrease of oxides of nitrogen from 1990 to 2014. So we have a look at 1990. I'm just going to make this graph a bit bigger so you can see it. 1990 is here, and it looks like it's 2.9. And it's just worth making a note of that. And then 2014 is here, between 2012 and 2016, and that looks like it's just above 0.9, which is a little below 1. So we're going to say 2014 equals 0.95. So we need to find out how much it's decreased from then to then. First thing to do is to work out the difference. So the difference between these two, I might just make this easier actually, just to make the maths easier. You do it properly, but just for the purpose of the explanation, there's a 2 difference there. So we've got difference of 2, and the percentage decrease in total, the total at the beginning was 2.9. So we do 2 divided by 2.9 times 100, because it's a percentage. I think it works out as about 66%, something like that. I haven't got the calculator, and I can't get the calculator on the screen, but it's something around about those values, 66, 67. If you use that properly as 0.95, I think it works out to about 67. And then give one advantage of reducing the emissions of oxides of nitrogen. Well, again, this was something you had to learn yourself about pollutants, and a couple of people did this well, but only a couple. So nitrogen oxide goes up into the atmosphere, reacts with water vapour in the same way that sulfur dioxide does, and produces nitric acid, which will then fall as acid rain. So if you reduce emissions of oxides of nitrogen, you reduce acid rain. Nitrogen oxides are produced when fuel burns in cars. It's the nitrogen from the air and the oxygen from the air reacting, but it only does so at high temperatures. It wouldn't do so normally. Okay, so that's the end of the test review. What you're going to do is look at the instructions on Teams and see how you're going to use this information to help you.